In this video tutorial, you will learn how to set logical nodes of the IEC 61850 information model for switching devices. Before starting to work with the configuration, we recommend that you watch the video tutorial opening and saving of configuration file. After successfully opening the configuration file in the project tree, select the Switching Devices section. This section presents switching devices and their parameters. Switching devices created in this section correspond to a specific logical node of the IEC 61850 information model. For example, the type of switching device circuit breaker corresponds to the XCBR logical node, disconnector corresponds to XSWI, other, to GAPC, used to control non-standard equipment. Consider the stages of configuring logical nodes using the example of setting the logical node of the disconnector. We recommend that you indicate the control name of the switching device in the title. The specified name will be displayed in the description field of the logical node and will allow you to determine the correspondence of the real switching device to its information model. The position signaling parameter can take two values, 3-phase and per phase. The 3-phase value is set for the switching device that has a common drive for 3 phases. The per phase value is set for the switching device that has a separate drive on each phase. In the information model, the switching device with common signaling is represented by one logical node and, in accordance with the standard, has its own sequence number. For example, the disconnector with common signaling that we are editing is presented as a single XSWI node. The switching device with phase-by-phase signaling is represented by 4 logical nodes, 1 common, and 3 logical nodes of each phase. Blocking nodes are created for each of the 4 logical nodes of the switching device. For the communication interface parameter, select the required Ethernet interface through which the disconnector will be controlled. And for the program protocol parameter, select 61850. The control model parameter is selected based on the required method of controlling the switching device from the upper level of the PCS. The following models are standard. Status only display of the position of the switching device without control option. Direct control with normal security, control of the switching device is possible by several clients simultaneously without feedback on command execution. Select before operate with normal security, control of the switching device with control capture by one client without feedback on command execution. Direct control with enhanced security, control of the switching device is possible by several clients simultaneously with feedback on command execution. Select before operate with enhanced security, control of the switching device with control capture by one client with feedback on command execution. If it is necessary to monitor the mechanical and switching life of the switching device, select a corresponding type from the drop-down list. You can learn how to set up the calculation of remaining life of the switching device in the video tutorial Estimating of Switching Device Remaining Life. For the types of switching devices disconnector and other, in accordance with the IEC 61850 standard, only monitoring of mechanical life is possible. In accordance with the IEC 61850 standard, for the type of switching device circuit breaker, it is possible to monitor the mechanical and switching life. If monitoring of mechanical life is selected, the number of switching operations will be displayed in the operation counter data object. When selecting monitoring of mechanical and switching life, in addition to the number of switchings, the sum of all currents of all performed switchings will be calculated, which will be displayed in the sum of switched amperes data object. If it is necessary to transfer the remaining life of the switching device, we recommend that you watch the video tutorial Estimating of Switching Device Remaining Life. For the IED with Bay controller functions, it is additionally possible to add and remove a switching device, as well as change the type parameter. The code of functional purpose can be viewed in the System Parameters section, IED Parameters tab. Next, in the Parameters area, specify the necessary signals for the selected switching device. For the closed state and open state parameters from the drop-down lists, select the logical position signals corresponding to the disconnector to be set. If they are absent, we recommend checking the setting of binary inputs for compliance with the project. You can learn how to quickly and correctly set IED signals in the video tutorial Binary Inputs, Outputs, Logical Signals and Indication. The next signals that we need to set are the trip permission and close permissions signals. Upon receipt of an MMS command from the PCS to close the switching device, and in case there is no generated closing enabling signal in the internal logic of the IED, the control command will not be generated. If the signal is not assigned, then by default closing will be enabled. The enabling of tripping works in the same way. For standard projects, these parameters specify the same control enable signal from the interlocking logic. If you need to configure the interlocking logic, we recommend that you watch the video tutorial Creation and Adjustment of Interlocking Logic and Switching Device Control Logic. In the data model of the ED2 device, according to the IEC 61850 standard, an option is provided for substituting the position signals of switching devices. In the substitution signed parameter, a signal is selected indicating that enabling of control of the switching device from the interlocking logic was generated using the substituted position values of one or more adjacent switching devices. Further, for the local control parameter, we indicate the signal generated when the local remote key is switched in the drive of the switching device to the local position. When the local control signal is generated, the IED will not generate a command to the internal logic of the device. For the tripping signal and closing signal parameters, the drop-down list displays only the signals of the virtual input module, which are used for control by MMS commands. For the tripping signal parameter, select the tripping command with the corresponding name of the switching device. For the closing signal parameter, select the closing command with the corresponding name of the switching device. If there are no corresponding signals, backup virtual inputs can be used. To do this, in the binary inputs section, we find a module of virtual inputs, which has backup inputs. We rename backup inputs to comply with our disconnectors inputs. Let us return to the switching devices section and assign the newly created signals to the tripping signal and closing signal parameters. For setting the control of switching devices by newly created signals, we recommend that you watch the video tutorial Creation and Adjustment of Interlocking Logic and Switching Device Control Logic. Please note that the module of virtual inputs used to control the switching device via digital communication protocols has 16 signals. If there are no free signals in the existing module, you can add an additional module from the library. Be sure to check the box for enabling the pulse mode. It is necessary to limit the duration of control commands received via the MMS protocol. Next, you need to name the commands and set them in the signals table of the IED. You can learn how to do this in the video tutorial setting binary inputs, outputs, logical signals and indication. Additionally, in the logic diagram, it is recommended to make sure that the functional control unit of the adjustable switching device has corresponding signals from the virtual module of binary inputs assigned to the close command and trip command inputs. It is also possible to reassign closing and tripping command signals to the functional control unit of switching devices. For more information about working with signals and the logic circuit of the IED, see the video tutorial on configuring ED2 devices, binary inputs, outputs, logical signals and indication, and creation and adjustment of interlocking logic and switching device control logic. This completes the configuration of the XSWI logical node for the disconnector. Logical nodes XCBR for circuit breakers, and GAPC for control of non-standard equipment are configured similarly. To check the correctness of the configuration, control the switching device using the MMS protocol. When editing is complete, you need to save it using the File menu or by clicking on the Save button on the toolbar. This video tutorial is over. We hope it was useful to you. Thank you for attention.